These little plasma cutters, absolutely marvellous. While they're being marvellous, and when they're not being marvellous, they're an absolute pain in the backside. So you're cutting along and then inexplicably they suddenly stop working. You change your consumables and they start working. You think, oh, that's the problem. Then they stop working. You change them again and they start working, and so on. And then you come to realise it isn't actually the consumables at all, because you've put back in the ones that we were using before. Where's the problem? Well, inside these things is a whole lot of electronic wizardry that I don't claim to understand, but I have managed to fix it. Now, first of all, if you're going to take the back off these things and meddle about inside them, there are 3 large capacitors there which can bite even when the thing isn't plugged in. So turn the thing around and short the capacitors out with something insulated. Now all you need to do is short the terminals like that. You don't have to do them all, but because they're all linked, but for safety's sake, just check them all. Now this thing hasn't been plugged in for a week or so, so there was no spark, but if it was plugged in a few minutes ago, you do expect a significant spark when you short it, and then the capacitors are empty and it's safe. So make sure it's fully discharged. You should take these things apart every now and then anyway, and clean the circuit boards off, especially these horizontal ones. That's all you need to do. This is contact cleaner, but any electrical cleaning aerosol will do the trick. Now this machine was fitted with 2 relays. Good ones are expensive and these ones weren't very good. They were on the other side of the machine. One was in there and the other was down there on the pilot arc board. That's all they are, quite simple little things with 4 terminals on the back. And I was so frustrated that I cut the top off one of them, and I worked it with a screwdriver and it still didn't work. So then I cleaned the terminals in it and worked it with a screwdriver again, and I actually got the thing working. There is a little bit of video here that I took when I did it. So this is the suspect relay just here. Cut the top off it so you can see what goes on, and when I pull the trigger you get absolutely nothing. That's holding the trigger down, having actuated the relay with a screwdriver. So I didn't want to spend 100 quid on a pair of relays for a machine that cost less than 200 quid. So what I did, I got some of these 24 volt 40 amp relays for lorry headlights. Simple things, and I just wired them in like this to see if the thing worked, and it was fine. They're super. And then it stopped working and I swapped the relays. I bought quite a few of them and it still didn't work. So I then narrowed it down to the resistance in the pilot arc terminal on the front, and following is a short video of my replacing the horrible little bit of steel threaded bar with brass threaded bar, and the machine works again. The connector off the front panel, rusty old bit of steel, never going to get good connections there, so I'm replacing it with a bit of brass threaded bar, which I'm cutting off this screw It's just long enough. I'm also going to use brass nuts and brass washers. There, so that's the new connector in. Let's see if it makes any difference. Oh, something as simple as that. So I started to dig a little bit deeper to see what else I could improve. So then I bought these relay blocks, relay sockets, which I'm going to fit inside the machine just there. I'm going to put an extra rail on, like this one at the back here. And I would probably put them on the outside if there was a convenient place to put them on the outside, but this thing is so small that isn't an option. Could possibly put them at the back where the regulator is and move the regulator somewhere else, but hey ho, I'm sticking them on the inside. I've put these two relays in. Now, one of the first things that I noticed then was that terminal there, right in the middle of the thing, which goes from the PCB to the main terminal for the torch, has a 5mm screw in it, and it's onto a 10mm lug, which is ridiculous. How can you get a good connection on that? That's the little screw. So I took the steel screw out, and I found that it's corroded on the contact areas, so we're losing juice there. So what I'm going to do is tap that little brass connector out to 6mm and put a 6mm lug on the end of this wire. It's a 16mm wire, and of course a bit of heat shrink. And at the bottom there we'll investigate, and I can see from here, whether you can, that it's held down with a rusty steel washer. So we're going to replace that as well and get everything brass. Gosh, take the pipe off. That nut is actually loose, so we're losing connectivity there. The lug does actually seem to be the correct size for the thread, so that's a blessing. But the nut underneath it, focus you, the nut underneath it isn't brass, so we'll put that right. And watch out here, because the washer that I thought was brass isn't. One of the nuts is, but that one is actually a brassed steel washer, which is going rusty, losing connectivity. So this is a piece of 16mm cable. On the business end, down on the front of the machine here, it's a real cheap nasty lug, but they've actually gone to the trouble of soldering it on. So I'm going to leave that alone and put a bit of heat shrink back on. But at this end it turns out to be a 25mm lug for an 8mm thread, which was held down with a 5mm screw. There's the screw. That lug was holding on. So that's no good at all. So I'm going to strip that off, put a correct size lug on, and put the thing back together. Well, I changed my mind. I made a new piece actually, slightly longer so that it isn't as tight as the original one. I've used the correct size lugs, crimped them on. Just need a bit of heat shrink, and the job's done. Well, as usual, things turned out to be more complicated than I expected. The attachment point inside the PCB for that thick 16mm wire might well be brass, but the nut behind it that I tried to tap out is steel, and it broke away from the soldered joint. So I had to unsolder it to get the bit of thread off because it's stuck on the tap, which has ended up being a good thing because I can now replace it with a nice brass nut. There we are, that's my new wiring and my upgraded terminal down there. I think the upgrading of the terminal was probably more trouble than it was worth, but once I'd started I was committed. There now, that's everything done, all the connectors replaced with brass ones, nice big brass lugs on it. Just because I had one, I've replaced the hose clip, didn't really need replacing, but I did. And then, same thing with the DINS connector on the front. Rotten old steel connectors on the back there. So I'm actually going to see if I can replace it with this larger sized one. Doesn't need it, but my other welding equipment all has the larger size, so I'll be able to use a longer earth wire and everything will be interchangeable, and that's always handy. Put the bigger DINS connector on. Oh, I was a plasma cutting virgin when I got this thing. I didn't know anything about them, and I obeyed the instructions in the manual, which said don't go over 60 psi, and eventually I found that you have to go over 60 psi. I'm working up at 100 and more sometimes, and it's just fine. The hose that came with it is rated at 10 kilograms a centimetre squared, which is 142 psi, and the only other pressure sensitive component is a little solenoid valve in there, which turns on and off the air supply to the torch, which is rated at 0 to 0.8 megapascals, which is 116 psi or thereabouts. Now, these things have a margin of error anyway, so you shouldn't have any problems at all going up to 120 psi. What's going to happen? Well, pipe might blow off or part might pop, but what the heck. And as for these relays that I have used, they're 24 volt automotive relays, so they're not rated to put the voltage through that these things put out, but they've been working for 12 months now and they're cheap, so what the hell. They're insulated, they're inside a box, and if something does go wrong, they're inside the other case and we're protected with an RCD, so I'm going to continue using them. Now, if your high frequency start isn't working, there are two little, I don't know what they are, spark jumpy things in there, a bit like the old-fashioned points in the car. If they're too far apart, it won't work. So you can try adjusting those, get them a bit closer together, and see if it makes any difference. It certainly did on this, and it also did on my TIG welder. That is a trial and error thing. I didn't set it with feeler gauges, but just to point you in the right direction, this machine is now working with a gap of about 30 thou. And here's one final tip. If you get yourself a plasma cutter, or if you buy a new torch, I've bought this pencil torch, get your sewing machine out and reinforce the sewing on the cloth cover, because they do an appalling job and it falls apart and you spend forever more untangling the wires. There we are, we're back in business. I hope this video helps somebody, and if it does, I would very much appreciate it if you subscribe to my channel It doesn't cost you anything and it helps me out.